Hi guys, this is Mike Hibbert back with another Django tutorial for you. This time we're going to cover the subject of how do you deal with a situation where you have a very long task to do on a website. Now, you may have come across a situation where you have something that a user clicks on a page and it triggers a process that seems to take for absolutely ever to complete, and then finally sends a message back to the user, and it's very confusing for a user when they click a button and then 5-6 minutes later something happens. Most users like to see things or a response from the site within a few seconds, if not less than that. So how do we actually deal with very long processes if we really want to have our website as responsive as possible? The answer to that is that we use a way of queuing tasks and having them execute in the background whilst the website still does its job. Now, to do that, using the Django framework, we have a number of tools available to us. We have something called Celery, which is a Python-based module which can be used in any Python application. But then we have Django Celery, which actually lets us interface to the Celery modules and then pass in information about processes that we want run from our Django installation. Now, Celery will then talk to another set of server software called a broker, and now the broker will basically take care of keeping a list of all these tasks that Celery's initiated, and then when time is available on the server in the processors, it'll run the task. Now, all of this basically adds up to the fact that you can then trigger a process, forget about it for a while, and come back and check on it at a later date after your user's gotten the response back from the website. So for instance, if you've got a task that takes 5 minutes and a user clicks go on the website, you can immediately send a page back saying I've started, and then you can then query from time to time over the next 5 minutes what the progress is, and then finally give a confirmation to the user that the process is done. Prior to that, websites used to just stand there and basically stall with a blank white page until the process was done, and it was up to the user to hope that it had been successful in the end. So it's obviously a more sensible way to deal with things by showing the user that things have started but they're not yet complete, and then giving them a message later in the time. So the first thing we're going to take a look at is how do we actually get a queuing server set up. Now, the one that I've picked for this tutorial is the RabbitMQ server, which basically is a bit of server software that listens on a web port, bit like a web server, but all it really does is it keeps a list of jobs that need to be done and executes them when there's time available to do that, and then reports back if there's been any problems or whether it's been or if it's been successful. So RabbitMQ is pretty simple to install. You'll notice here that I'm not actually inside of my virtual environment at the minute, because this is server software, so we need to install this actually on the box itself. If you use this on a remote server, you'll need to install it on there in some way. If you're going to do that on Heroku, for instance, there's a way to add that in through the control panel and also through the command line programs that Heroku supplies to you. But we're going to just do this locally, just so we can actually show that it does all connect together, and then installing it on a remote server should be a fairly simple task once you've done this part of the process. So the first thing to do is we're going to use Aptitude to install RabbitMQ-server. Now, the reason why I'm using Aptitude and not apt-get is because Aptitude is a bit smarter and can work out for us, without us doing any work, which modules need to be included with this installation. So if we run aptitude install RabbitMQ-server, then that should install everything that we need with it, if there are any additional modules. So we do that, and as you can see, I've already installed it myself, but you should then get a long line of some of the modules that go along with that. And then once you've done that and it's completed, everything should be installed ready. So we've just basically got to configure the server now, and the server needs configuring with two things. It needs first of all a user that has permissions to actually use the queue, because obviously this is a web-facing server. Then it could be abused, so we need a user with a username and password first of all. Then we need an actual identifier to say which site this particular queue is being created for, and then we can then configure that with some permissions and give the user some access permissions to that particular configuration. So the first thing we need to do is we need to use the command. I've lost it. I'll do it from scratch, never mind. We need to use RabbitMQ-CTL, which is RabbitMQ control, and the command we're going to use is add user, and we're going to use the username Mike and a password of cheese. Now once we execute that, it'll create the user and set the password to that, and then we need to create our identifier. Now the identifier basically lets us separate the one specific set of queued tasks into something that is tied or bound to our Django website. So with RabbitMQ, this is called virtual hosts. It's called that with Apache. There are other queue systems where it isn't necessarily called that, but in the case of RabbitMQ, it calls it a virtual host. So the command we use is add vhost to add this in, and what we're going to do is we're going to just call it /Django tutorials. Once we execute that command, it'll create that virtual host in the system, and then when we start to add tasks later on, we'll find that they'll all be collected under the heading of Django _tutorials, and that means we can also separate a queue off for another website and have that, I don't know, myshoponline.com, and that would have a virtual host for there that would have its own set of queued tasks. So in that way we keep things separate, but we also can restrict access. So we need to then configure what the user Mike has in terms of access to this virtual host's queue. So to do that, we use the set permissions command, -p, then the name of the virtual host that we want to configure. So it's Django /Django tutorials. No. There we go. And the user that we want to configure with this is Mike. Now, next we have three different regular expressions that tell the RabbitMQ control what kind of permissions access Mike has under the Django tutorials virtual host. So the first one is what kind of permissions does it have for for configuration, and for this we're using a wildcard, and it's basically a similar idea to what you'd see when you're trying to search for files and you do ls-l ****, or in Windows you do dir ****. It just basically matches anything. So we're just saying for configuration, Mike has the permissions to touch anything inside of this queue, and that's fine for our local host development. The next regular expression is again the same thing, but what that relates to is write permissions. So that's the ability for us to create the queued in tasks. And the last section is again match anything, but for read permissions. So write lets us create jobs, read lets us check on what their status is. So with that, we've got three permissions set for Mike, saying basically let Mike's account have full access to this Django tutorials job queue. Once we run that, that gives that all the permissions we need to continue. So if you press enter at the end of that, then that should run that fine. I'm not going to do that because I've already done that and I don't want to screw up my installation. The next part is basically that we want to restart the server itself, because we've changed some configurations and we want to reload the server properly. So to do that, on Ubuntu we need to call the script that would be run normally when the server actually starts up, and that's usually called from inside of the ect init.d folder. And the one we want is rabbitmq-server, and we're just basically going to say stop, and that stops the server. Now the reason, if you run that without the stop command, you'll see there's a few other little options that we could have used. There's start, stop, status, rotate logs, restart, conditional restart, try restart, reload, force reload. So we could have done all those things, but in this case, because it's a new installation, I just wanted to start it off like it had just been restarted as a whole box. But we don't actually really want to restart the server. We just want the software to reload all the settings. So we're doing that, and we're just going to say start again. So that's the server restarted and configured. The next bit is to basically go inside of our virtual environment. So with this we go bin activate. Now notice I'm using a dot instead of the source command. This dot here is effectively the same as the source command, so if you want to do this in a shorthand way, you can just use the period. It really depends on you, and it doesn't really make any difference in the long term. So you do that. Now we're inside the virtual environment. We want to install our Python side of things. Now we've got our Q server running. We want to install Celery and the Django Celery modules, so that we can then interface through Celery from our website into RabbitMQ's task list. So to do that, we're using pip again. Pip install Celery and Django. Oops. Excuse me. And Django Celery as well. Got a frog in my throat. So if we run that, it should then go away, download some software. It'll show you that there's a few more modules that it needs to install alongside that, like Billiard, Python Date, Util, Kombu, PyTZ, AnyJSON, and AMQP. AMQP is a protocol that's used by RabbitMQ when queries are sent to it through its web port. It uses that protocol, very similar to how a web browser uses HTTP to query a web server, and then the web server sends back an HTTP response back to the web browser. In the same way, RabbitMQ uses AMQP as its transport mechanism. Okay, right, so that is installed. The next step is to basically create ourselves a new app that's going to demonstrate how this whole queuing process works through code. So to do that, we need to go into Django test, and we want manage.py. Manage.py, start app, and we want celery test. And if you run that, it should create for you inside of there a folder, inside of your Django test folder, a new app with a models file, a tests file, and a views file. Now we're going to add to that by creating a tasks.py file. Now I'm not going to show you what's in there straight away, but just so that you know, you'll get these as a default with the ini file, but this is one that we add in by hand, and this is going to actually take care of defining what our tasks are. So we'll cover that in a moment. Let's just kind of carry on with what we're trying to do here in terms of setting up. So we do the start app command, and that'll create the folder with those extra scripts. The next thing for us to do is we need to go into our settings.py file, and we need to add in a couple of entries into our installed apps section. So what we need to add in there is, first of all, DJ Celery, which is Django Celery module, and that's the one we've just installed before, and also the newly created app. So that should then recognize that we've created that app and include it in. The next thing we need to do is we need to add a few settings so that the DJ Celery system can then do a bit of configuration and know how to connect our host. So the first thing we've got is broker host. Now the broker, as I might have mentioned earlier, is RabbitMQ, and basically it's called a broker because it takes care of getting the transactions carried out. So that's what a broker does. So the broker's host is obviously our local host at the minute, so just the IP address for my machine on the local host. The port is the default port, which is 5672, and the broker virtual host that we're going to identify with is Django / Django _tutorials. The user was Mike, that was set, and obviously we set the password of cheese. So you can set those to whatever you want, but they must match when you set up RabbitMQ. These must match what you set up in there. And then the next thing is we're going to do something similar that you might have seen when we did in the admin interface for Django. We did an import of the admin and then ran a function which is getting run inside of the setup code. Now this particular thing here is just basically importing the Django Celery library and then running the setup loader. What that does is it does a bit of auto detection, gets everything set up for you without you having to do a massive amount of coding to make it all plug together. So it's basically for your convenience along the lines of how the admin interface does that. It basically does a quick search through all the models and finds out what's available, and that's what this does also, but in terms of what it's trying to accomplish with the Celery system. So that's our configuration setup. Now we need to then do a couple of bits of code with our models and also bring in our new tasks. So the model is very simple. For demonstration purposes, this is not really going to get very complex at all. We're just basically going to create a model like we did in our previous tutorials. We're going to add one basic field, which is an integer field called count, and we're going to add in a Unicode function that just returns the count as a Unicode string. Oh, excuse me. And that's that. That's all we're going to do for that model. Nothing complicated, but you'll see why we do that in a moment. If we head over to the tasks file, this is completely empty at the minute. This is the task file that we've created inside of our Celery test app. So tasks.py it's called. And in there, the first thing we do is we bring in a few imports. The first thing we want to import is from celery.task. We want to import task. Now task here is actually a decorator function. So this decorator will allow us to encapsulate our customly defined functions as tasks that Celery understands, so that we can then take advantage of some of the functionality that Celery has parceled up inside of it when we run our functions. The next bit is just to bung in our model that we've created, because we're going to use that inside of our function. And I'm going to import sleep from the time module, because I'm going to use sleep to actually create a function that runs a bit longer than it should do. And in this case, I'm going to make it go for 10 seconds more than it should do. So we've imported those. First thing we're going to use is the task decorator, and then we're going to define a function underneath, so that this task decorator wraps around this function. And the function is very simple. It says add two numbers. Then I've put a little bit of text in here just to say this is where you'd normally put the bulk of your work when you're doing a queued task. So you'd normally put all your processes and that sort of thing inside of these functions. If you have a different function that does something else, then you'd have a bit of code in there as well. But for the sake of demonstration and to show the point of how things can take longer than expected, my sleep function is going to make it all pause for 10 seconds. And then after 10 seconds, we're just going to basically create a new count model instance and set it to a plus b for the count member variable, and then just return the newly created record. And that's pretty much it. That's all it's going to do. Nothing complex, but it will demonstrate the point that I'm trying to make about how long processes can take. So with that, we then need to head over to our Django installation, and we need to now run a bit of migration code for South, so that we can then update the databases. So the first thing we want to do is manage.py schema migration for Celery test -- initial, because it's the first time that we've actually introduced this new app. So this will be an initial snapshot of what the database tables should look like, and then we run that, and that should create our first migration. The next step obviously is to just say migrate. So that's migrate. So manage py migrate, and that will install all the newly created tables. It'll also include the DJ Celery tables that are needed to track things within the Celery system. And then that's pretty much us set up. That's all the configuration that needs to be done. So we just need to test it now. And the way that we're going to do that is we're going to use a newly added set of functionality. Now, when we add things in to the what's the word, installed apps, very often if they have extra functionality that they need to add to the Django framework, they often add commands to your manage py. So For instance, Haystack did that. So did South. But as well as that, DJ Celery does the same. It adds in a new set of commands so that when you do manage.py, next to where Haystack and South put their new things, you'll see a new section here. And in there's a new set of commands. And the one that we're really concerned with is Celery D, which is the Celery daemon. And that is basically a daemon that sits there and manages the whole token from Django Celery through to the RabbitMQ server. So we need to run that, and the way that we do that is we use the Celery D command -l info, and what that'll do is it'll start the daemon off watching for new requests. It'll connect through to the RabbitMQ, which you can see here now. When I was talking about protocols earlier, AMQP is the protocol that it's talking across the network to on port 5672 through to our RabbitMQ server using the AMQP protocol. So if that had been a web server, that bit would have said HTTP, but in the case of this, it's a Q server, so it uses something completely different to define what the protocol is. Now we've set that going. What we need to do now is we need to basically open up the Python, the Django shell. So we want manage. Oh, am I in the right place? No, I'm not in the right place. That's why. Manage.py shell. And this opens up the Django shell, which lets us have access to all of the modules within the Django installations path. So what we're going to do is we're going to go from celery underscore test dot tasks import add to numbers. Okay, so that's imported the function that we've defined inside of our tasks file. Now here's a demonstration of what running this function would be like if you just ran it straight from your web page. So say we say add two numbers, add number 1 and 2 together. Answer should be 3. So we run the function, and what happens? Yeah, it stands there for 10 seconds holding up the web page refresh. The user gets a nice white page that doesn't tell them anything, and they think, oh, website's broken, and then suddenly a result comes back. Now that's fine for 10 seconds, but say that takes 5 minutes and the user sat there with a white page all that time. They're probably going to think your website's broken. So in the case of a very complex and long running task, we don't do that. What we do is we use the delay method that we added using the decorator, and instead of putting our parameters in like we did here, we put them in here instead. Oh. And then that basically runs the decorator code that then says this is a delayed task that needs to be put into the RabbitMQ system via the Celery module with these arguments of 1 and 2. So this is effectively the same as running that code, but it has the added feature of sticking it into a timed queue that can be run later whilst our web server is continuing to do its job. So we do that, and what do we get back? We get an async result, which is a different result from here because we've got a counter model with the answer 3. This time we've got an async result as a return, and this here is the ID. So this is the actual ID of the async result that's been sent into the server. So if you wanted to store that, you could then come back at a later date and requery RabbitMQ to say, I've got this ID, and I'm looking for the status of that current async result. Has it been a success or has it failed? So it's probably quite useful to store these when you're actually using them in a web page. So let's just look back at the actual server. We can see here, got task from broker, add 2 numbers with the function. There's the ID inside of it, and we can see in the next line down, succeeded in 10.39 seconds. And then it shows you the return result here instead. So, what if we wanted to query things at a later date? Well, what we could do is we could store the result from this. So, if we just went result equals, and then run the function again, we get a result. It gets acknowledged by being on here. However, if we go back and go result dot status, it says success. So I'm presuming if we go back to our logs, yeah, we can see that the task succeeded. However, if we quickly do that before the 10 seconds up, we should then see pending. So we can still see that that's waiting. Another thing we could do is say successful instead. That says it's true, and that's probably because it's over the 10 seconds now. Yeah, and as we can see, it's succeeded in the list. Let's trigger another one, a new job. Now check successful. False. So until that's completed, these different methods will show different values. And now it's true because it's completed the job. Okay, I hope that you enjoyed this tutorial. If you did, then please click the like button. If you want to know more about the tutorials in this series, then please click the subscribe button and we'll send you a notification as soon as a new one is available. Thanks for watching.